Okay. So today we're going to talk about nonlinear inequalities. Okay. So this is what I would like you to do on your calculator and discuss it with your pod. Okay. So I'm giving you x squared plus x minus 6 as your function. What I want you to do is graph it on your calculator and think about these three things. When is f of x greater than 0? How would you write your answer to that in interval notation? And what were the most critical points when considering your answer? Okay, so graph it, talk amongst your pod, and we'll come back together and discuss it. All right, I'm hearing some pretty great discussions. I'm pretty happy about it. Okay, here's your graph, right? Okay. So Matt, just describe to me, when is f of x greater than 0?
It's greater than 0 after the x-intercepts.
After the x-intercept.
Wait.
So up here where our graph is positive, right? Okay, so writing that in interval notation, how would we write that in interval notation? Anyone want to give an idea?
So it would be like negative infinity, to negative 3, and then 2 to 3.
And will we put brackets or parentheses around negative 3 and 2? Parentheses. Okay. How do you feel about Amanda's interval? Do you agree? From negative infinity until 3, we are positive. And from 2 to infinity, we are positive. We're above the x-axis, right? Okay. So what were those most critical points that you were considering when you were dividing up what your answer should be? Where it crosses the x-axis, and we know those to be our x-intercepts. We also call them zeros, and we are rock stars at finding zeros, right? Okay, so what we're going to do today, we're going to solve inequalities that aren't necessarily linear, okay? You guys can solve linear inequalities. 5x minus 5 greater or equal to 3x minus 2, okay? You can get the x's on one side, everything else on the other, and have an answer, right? Okay, well now we're going to look at non-linear. So the first ones we're going to look at are going to be polynomial inequalities, okay? So, when we are solving polynomial inequalities, what is one thing that we need to consider before we break up our intervals? You just told me you had to think about the x-intercepts, correct? To figure out if we were above or below the x-axis. Okay? So when we solve polynomial inequalities, okay, we are going to have to find those critical values. We're going to have to find zeros. Okay? Then what we are going to do is we're going to test our intervals, okay? So we're going to break our x-axis up by our zeros, and then we're going to have to figure out, is our polynomial positive or negative in between our zeros, right? And so we're going to test values in between zeros to figure out if we're positive or negative. And there's going to be two different ways we represent our answer. Where I'm going to either ask for a number line and or interval notation. The most important thing is finding those critical values, find those x-intercepts. Where is our polynomial zero? Okay. And then we're going to test our intervals based on those critical values. All right, so we're going to do a polynomial example, and then we're going to look at what happens if it's rational. So, first example, please write it down. Before we start finding our critical values, what should we do with this inequality first? I would not do that yet. Why?
Would you move the 4 over?
Okay, we first need to set it to 0, okay? Because if we're looking at the zeros, okay, we need to look at when our inequality is 0. So we first need to move the 4 over. So x cubed minus 4x squared minus x plus 4 is less than or equal to 0. Okay? So we're looking at where this polynomial is less than or equal to 0. So now that we have it set equal to 0, let's find our zeros. How would you like to do that? Kyler would like to factor by grouping. Is that okay with you? If you can factor, it's going to be quicker. All right, so factor by grouping. GCF of the first two. Left over is x minus 4. GCF of the second two. Minus 1. Left over is x minus 4. So then we can factor this to x minus 4 times x squared minus 1, which then can factor to x minus 4 times x minus 1 times x plus 1. So where are our critical points?
4 plus minus 1 or 4.
Okay, so 4, positive 1, negative 1. Okay, so we're going to draw a number line here. and we have zeros at -1, 1, and 4. Okay. So we're going to test these intervals, okay? We're looking for when this polynomial is negative, correct? Less than or equal to 0, okay? So let's test a number to the left side of -1. What number could we plug in that would be to the left of -1?
-2.
Okay, and if we plug in -2 to this right here, is it going to be a positive or a negative number? -2 cubed would be?
8.
Okay, so -8. 4 times -2 squared, that would be, so we have -8 minus 16 plus 2 plus 4. So is it negative? Okay, so we tested -2, yes. This is a negative interval. Okay, I'm just going to kind of make a note to myself. What about in between -1 and 1? What could we try? 0. When we plug in 0, what do we get? We get 4. Is that negative? No, that interval did not work. Between 1 and 4, we can plug in 2. So we would have 8 minus 16 minus 2 plus 4. It's a negative, isn't it? All right, so that one worked for us. To the right of 4, if we plug in 5, we would have 125 minus 100 minus 5 plus 4. What? It'd be positive? Positive 24? Okay. That's not what we're looking for, is it? Okay. So the intervals that work are to the left of -1 and in between 1 and 4. Okay. Now, first of all, do we get to include our zeros in our intervals? Yes, because we have this equality right here. Okay, so when I make my number line answer, we can include -1 all the way to infinity. And then we have between 1 and 4, and we can include our endpoints. So in interval notation, we would write -infinity to -1 and 1 to 4. Okay. Make sure when you are testing your intervals, you're testing to see whether they're positive or negative. Okay, but always go back and look at your inequality that you set to 0 to see if you need to look for whether it's positive or negative. Sometimes you're going to have less than 0, sometimes you're going to have greater than 0, so make sure you look at that before you start testing your intervals. Okay? Would there be another way to do that, to do this without having to plug in 4 numbers to our equation? Well, we already found the zeros. But after we found the zeros, like we plugged random numbers in, right, in between our intervals to see if it would work or not, would there be another way to figure out where we're positive or negative? Okay. Well, you're not going to have a graphing calculator, but could we think about the graph? Okay. If we know that we have zeros at -1, 1, and 4, we know that our polynomial has a positive leading coefficient, an odd degree, and each of these have multiplicity of 1. We can think about that graph fairly quickly, correct? Okay. Where is our graph negative? Here and here. Okay. So if you would like to think about the graph instead, that is fine. If you would like to test intervals, that is fine. Okay. But you will need to be able to express your answer both in interval notation and number line notation. Okay, it's going to ask for both.
So do we actually need to draw the graph if we're gonna do that? Or like,
You can sketch it off to the side, or you can, yeah, I would sketch it off to the side. All right. What if I gave you an inequality that was rational? Okay. So here, I have this inequality, and I have the graph. I want you to look at that and think about what our critical points would be here. What would be our critical values if we had a rational function? Would 0 still be critical? Okay. Is there anything else we would need to consider? Our asymptotes, okay? X can't be 2 in the denominator, and so we have an asymptote here at x equals 2. And you'll notice that sometimes we have different behaviors on either side of our vertical asymptote. So here, we have negative values. Here, we have positive values, okay? So not only do we have to think about our zeros, but we also have to think about our asymptotes, okay? So here's this inequality, here's the graph. We're looking for when this function is what?
It's
Greater than 0. So where is this function greater than 0? Okay, well at -5, that's our 0. So is it, where is this above 0? To the left or to the right? Okay, so from -infinity to -5, we're positive. And when else?
2 infinity.
Okay, after 2 to infinity. Yes,
So we don't do brackets because there's time.
correct. So since this was just a strict inequality, everything is parentheses, no matter what. Okay, so now if you have a rational function, you still have to consider the zeros, but we also have to consider the asymptotes as well. Those are going to be critical as well. Now, if you look at this function, what would be an easy way to identify an x-intercept? Our x-intercept was -5. That would be for a y-intercept.
Solve.
Put in 0 for what? Okay, we have to set it equal to 0, right? And if we have a fraction that equals 0,
So,
we really only care about where our numerator is 0. Because if our numerator is 0, the whole fraction is 0. So if we can identify where our numerator is 0, those will be our x-intercepts. Okay, so let's do an example. Is this inequality set to 0? No. Which means we need to do what? We need to subtract that 3 over. Now what will we need to do? combine these two fractions together. Okay, because if we have one fraction, we can easily identify where the asymptotes are and where the zeros are. Okay, so how do I take these two and subtract them? Okay, what's our common denominator? So this is going to need to be multiplied by x minus 5 over x minus 5. Right? So we have 2x minus 7 over x minus 5. And we're going to subtract 3x minus 15 over x minus 5. Right? Okay. Please be careful when you are subtracting fractions. What does our numerator become? Negative x plus 8. Okay. All right. Yes. Because that's what the denominator was here. So we just, They're okay with this plus 8. We have negative 7 minus a negative 15. Be careful. All right. So this is what we need to work with from here on out. Let's make a number line. Where is our vertical asymptote? At 5. So that is a critical value. Where is our fraction 0? At 8. So that is another critical point, where we are 0 in the numerator, where we're 0 in the denominator, okay? That's how you can remember it. Now, let's test some intervals. Okay. What's something to the left of 5 that we can pick? 4? Okay. When we plug a 4 in here, it would be 4 over negative 1. Okay. So if we plug in 4, this is negative. Is that what we want? Okay. Between 5 and 8, 6 is pretty easy. This would be 2 over 1. But we want it to be less than 0, so that's not what we want. Right? Above 8, we can plug in 9. If we plug in 9, we would have negative 1 over positive 4. Is that negative? Is that what we want? Okay. So there's our intervals. So we know to the left of 5 is good, and we know to the right of 8 is good. Okay. Bracket or parentheses on 8? Bracket or parentheses on 5? It is an asymptote. We cannot include 5 even if we have this equality right here. 5 will make our denominator 0, making our fraction undefined. It will never be okay. All right, so if it is an asymptote, you have to put a parenthesis, no matter what.
Does it always go like yes, no, yes?
Not necessarily. Okay. Okay, so Kyler was asking, is it always going to go yes, no, yes? Like, is it always going to alternate? What I want you to think about is like a polynomial. If we had multiplicity that was even, this one would be, like if we were looking for where this one was positive, would be no, yes, yes, if we broke it up by the zeros. Okay, so it's not always necessarily going to alternate, but if you know what the graph's going to look like, you can kind of get an idea of what's going to happen. Okay, I would always test your intervals just to be safe. Okay. Other questions? That was really good. Before you find critical values, what must you do to your inequality? Set it to 0. Okay, please set it to 0. Okay. All right, so this is your last homework assignment in 2.7. Okay, our test is on Thursday. There is something that I would like to show you that you may have seen in your book. You may have not realized that the book was telling you. Has anybody noticed, like, at the beginning of every homework assignment in red, it says, go to calcchat.com for a worked out odd solution? No one has seen that? I would like to show you CalcChat. Okay? This is a way for you to, like if you're working on your homework at night, and obviously I'm not there to answer your questions, or you don't have, you're not working with somebody at all, okay, if you're working on an odd problem, this is a way for you to maybe get a little bit of help, not copy an answer, okay, but to get help with how to work out a problem, okay, so let me, okay. So calcchat.com. Okay, this is what it looks like. We are taking pre-calculus, and our book is the pre-calculus with limits. So this pre-calculus with limits, if you click on it, that looks like our book, doesn't it? Right here? Yes, okay. So we can click on it. All right, and then you can do this. You can go to chapter 2. We are in section 7, and say tonight you're really struggling with number 45. So you can go here to number 45. Go. And they have some solutions worked out for you. Okay. Now, it may not be exactly how I would work out a problem, but sometimes it will be, sometimes it won't. But it's an option for you to go and look at a solution if you're really struggling. Sometimes if you can look at a solution and you, oh yeah, that's where I made a mistake, and you can fix your work, okay, that might be nice. Okay. This is not to go and just copy all of their work and not do any for yourself, right? But if you need it for odd problems, it is there.
School and Rachel Goldstein's already learning CalcChat for her homework.
Yes, you can also tweet and follow them on Twitter if you would like. Okay. All right, so there that is. Like I said, if you need it, it is there. Okay.